Hello everyone, thank you for joining me for this session on the cutover, moving your traffic to the cloud. I'm Tino Tran, I'm a Principal Solutions Architect with AWS, specializing in migrations, and as you might have guessed by the title and my specialization, this is going to be a migrations talk, and we're going to talk about a very specific part of the application migration process, particularly the part where you're moving your production traffic from your source environment to your new environments in AWS, right? Now, this is a 30-minute, 400-level conversation, so we're not going to be able to boil the ocean here. However, we are going to provide you with some advanced techniques and patterns that you can leverage using services like CloudFront, Amazon Route 53, as well as database migration service to execute your migration. Okay, so to help visualize this, right, to me, moving application traffic is kind of like switching lanes when you're on the highway, right? It's something that you know how to do, right? But you may not think about it until you actually get to that milestone, right? In either case, you still need to make sure that you take all the appropriate steps so that you can transition safely. So in this example, we have a taxi cab that's on the cloud highway, and we need to get off this exit to go onto AWS and continue our journey, right? But we don't just switch lanes without thinking about it, right? Because bad things can happen. You might get in an accident. You might startle your passengers, your customers inside the cab, right? So you look around, and sometimes you have cars on the road, right? So you want to notify them. You want to notify all of the stakeholders that are involved, and then you can switch lanes. Now, when you go ahead and switch lanes, there's a few ways to approach this, right? You could go pretty quickly, and sometimes that's okay if nobody else is on the road. However, if there are other cars on the road, you run the risk of cutting them off, creating a road rage incident, maybe even an accident. And your passengers inside might get motion sickness even, right? So, these are things that you want to think about as you're migrating your workloads and cutting over that traffic. Ideally, you'd be able to migrate, cut that traffic over a little bit more gradual so that you can kind of test the waters and mitigate some of that risk, right? But nevertheless, regardless of the approach, these are things that you need to think about. There's a time and place for, different ways to cut over, right? And ideally, with the right planning, you can have a successful and safe journey, take that exit out of that data center and migrate into the AWS cloud. Okay, so what could go wrong, right? When we go and plan a migration, there's lots of things that come into play. We think about things like what the application is, what the dependencies are, and how we're going to move that application. But then we get to this phase where we're cutting over, and this is actually one of the most critical phases, right? Because this is when we're playing with actual production user traffic. So, what could go wrong, right? Unplanned outages, loss of data, missed scaling expectations. These are all things that could affect your migration if you don't plan well enough for this cutover phase. So at AWS, we're very customer obsessed, right? And we want to make sure that all of our end users and your end users have the best experience possible. So it's very important to kind of plan this phase out in detail. Now, we've seen applications migrate to the cloud in a number of different ways. Everything from migrating the entire application stack to just the data layer to the independent components within the application stack. Maybe you already have a microservices architecture and you can move individual services or components or data sets into the cloud, right? Well, in this talk, we're gonna cover these areas and cut over strategies for all of these different types of migrations. Okay, so I mentioned before, preparation is critical. We do a lot of planning throughout the migration phase. We also need to do this planning for this cutover phase, right? You want to make sure that one of the recommendations that we have is that you do an operational readiness review, right? And what this is this is the ultimate checklist that you would have to make sure that all of your action items are covered before, during, and after the migration, right? You want to make sure your testing is complete. If you have load tests that need to run, regression tests, performance tests, make sure those are completed. Make sure you understand what your account limits are and that they'll meet your expectations in terms of scale and capacity. Right, so these are things you want to think about. In addition to this, you also want to make sure you have the right metrics and dashboards, right? You need visibility into how your application is performing, as well as what your end user experience is. Otherwise, you could go for periods of time without really understanding if the cutover was successful. If you have thresholds that align to your SLAs, you should consider setting those thresholds and using services like Amazon CloudWatch. Maybe you configure an alarm so you know how to respond in the event of an unexpected crossing of that threshold, right? And when you actually go to respond, you want to make sure you have the right runbooks in place. And what we mean by runbooks is, you want explicit instruction sets on what to do throughout all of these operational tasks, right? If it's just the cutover, then you need those to detail that out. Maybe it's a way to manage or operate the service in the event of an unexpected situation, right? Many times we overlook some of these common day-to-day tasks, but in the heat of the moment, it's easy to introduce human error into the process, and having runbooks is a way to mitigate that. And even better than that is to automate your runbooks, right? Automate as much as possible. With AWS, we also have a service called AWS Systems Manager, where automations are built into the service. You can use some of the automations already baked into the service for common operational tasks, and you can also build and develop your own custom automations into the service as well. Next, let's talk about setting a date and time for when you're actually going to execute this migration cutover, right? You don't want to just pick any random day because you feel like you're ready. You want to make sure you pick a day where all of your stakeholders are ready and will be available. Anybody who's involved in the migration, right? You also should look at your application traffic patterns. If your application has a cyclical traffic pattern, you want to potentially start at one of those periods where you have the least amount of traffic and watch it gradually ramp up. This will allow you to reduce that blast radius, right? And we talked about stakeholders, but when you think about stakeholders, you really want everybody who's impacted by the migration to be aware, involved, and accessible, right? Lots of times we see customers set up these war rooms with conference bridges on the day of the cutover, and this is where you can quickly access. People know what their responsibilities are, and if something goes wrong, we know where we can begin looking, right? Another thing is you should consider what level of AWS support you need, because if you have premium support, AWS could be there to just support you through the event, right? These are all things that you should think about in getting ready to execute the migration. Okay, so I talked about support on the last slide, but one of the offerings we provide is called Infrastructure Event Management. With Infrastructure Event Management, which is available if you have business or enterprise level support, we will work with you to understand your success criteria and your desired business outcomes. We'll assess the readiness of your AWS environment. We'll help identify and mitigate any risks along the way. And then we'll work with you to document a plan. With all of that, you'll be able to confidently execute your migration, and we'll even bring along SMEs into the process so that you can execute the cutover with confidence, right? Now, after the migration, we'll even help do post-analysis. We'll take a look at what the scale of the service is under normal conditions and make sure that the services you're leveraging can operate at normal levels. All of this so that you can focus on your next migration. Okay, so we talked about preparation. Let's go into actually how do we move traffic to the cloud, right? If you look at a typical application deployment, in this example, we have a 3-tier application, web, application, data layers. You may also have APIs. Ultimately, what it all comes down to when you're moving traffic is how do you get your end users to the correct endpoint? And on the public internet, the most common way of doing this is by using DNS. Right? DNS is the way to look up the application endpoint. It returns an IP address, and your end clients can then connect to that IP address, right? In some cases, you may have additional infrastructure outside of your web application stack, in which case, for instance, in this example, we have a content delivery network. Regardless, DNS is the mechanism that routes your end users to those endpoints. Okay, so let's do a quick primer on DNS. This is something you've probably seen in your college textbooks. But when you make a query to DNS, let's say you go to www.amazon.com, right? The first thing your browser does is it makes a query to its local DNS resolver. And then that resolver, if it doesn't have the answer, will actually make a set of recursive queries to several different name servers. The first one being the root domain name server to find out where all the .coms are hosted. Then it'll go to the top level domain name server to find out where Amazon.com domains are hosted. And then it'll go to that authoritative name server to fetch that IP address. And from there, the browser can then connect to that IP and start sending requests, right? Now, that's a lot of queries, and the internet's all about speed and performance. So how does DNS reduce this latency? Well, it introduces caching, which is pretty commonly used, right? So on subsequent requests from that client or other clients resolving against that DNS server, it'll already have the answer and not have to do those recursive queries. Okay, so how does that affect your cutover when you're configuring your DNS, right? Well, in this example, we have a corporate data center, and then we have a cloud, our cloud environment where we've deployed our target endpoints, right? So let's assume we've migrated the application, we've deployed it, we've already synced the data at the data layers, and we're ready to execute that cutover. Well, typically, the first thing we see happen is customers will lock the database so that you don't lose any data when you're cutting over, right? You don't want any data that didn't get replicated over, so you'll lock your databases first. Then you'll update your DNS records to point to the new IP address, and ideally what you'd expect is your clients would resolve against their local resolvers, get that new IP addresses, and get routed to your new AWS endpoint in the cloud. Well, because of what we talked about on the last slide, we know that this isn't always going to happen, right? There's millions of domain name servers, or lots of domain name servers around the world, and some of them could be caching these answers, and as a result of that, there's going to be some propagation or lag to that, and some of your users will get the wrong answer. They'll be directed to the original endpoint. So some things to think about here when you're configuring DNS for your cutover, right? You want to take into consideration caching. And when DNS is configured, a TTL, a time to live, is configured on the record to determine how long the name server should cache them. Something you can do in advance of that migration is to reduce that TTL value to a lower value, maybe 60 seconds, let's say, right? So that these resolvers are polling more frequently, reducing some of that propagation lag. The other thing is, if you have globally distributed users, right, you can use a DNS checking tool to check to see where you're at in the propagation of that update to the record. The way these tools work, and you can search for them, they're available on the internet, they have servers around the world that query local resolvers, and they'll tell you what answers they're getting, and it gives you an idea of how far you are behind. The last thing is you want to take into consideration client behavior, right? Some clients don't respect the TTL. For instance, browsers. Many browsers are trying to load the web page as fast as possible, and one of the ways they do that is by caching the DNS answers themselves right in the browser, right? So it doesn't matter if the resolver's caching it, they're also caching it, right? So you need to pay attention for these things. In some cases, you may have custom clients that are holding on to an IP address or holding on to a persistent connection to your original endpoint. So ideally, what you want to do is have metrics around this, and this is where dashboards are super important, right? In your source environment, you want to have dashboards that show how many existing connections there are, how many new connections are being created, and you should be prepared to terminate those connections if you really need to, and force those clients to re-resolve. Okay, so those are some things that you want to think about when you're cutting over with DNS, but how do you mitigate some of these propagation issues, right? Well, one way you can do this, if we go back to our example, is we lock our database, we get resolved to the old endpoint. Rather than returning an error that you would normally expect when the database is locked, you can build application logic into your application to handle this and actually configure a 301 redirect to a new endpoint, right? And with the HTTP protocol, a 301 is a permanent redirect to a new subdomain. And in this case, we introduce a new subdomain, cutover-2.example.com. With that, the browser, if it respects HTTP protocol, would know to retry against a new domain endpoint, and that domain endpoint we could configure to point to the new AWS environment, right? So what your DNS configurations would look like is you'd have two of them, one with the original domain and one that would be temporarily used for these redirect use cases that also points to that new endpoint. Okay, so when you do migrations, lots of things happen, and there's already a bunch of complexity built into the whole process, right? So sometimes updating application logic is not necessarily helping with that complexity. One of the things that you can consider leveraging to abstract that application logic from your application is to use a service like Amazon CloudFront. If you're not familiar, Amazon CloudFront is a content delivery network, and content delivery networks are distributed networks of what we call edge locations around the world that provide a service to end users, right? And these edge locations are often called points of presences. And in these points of presences, you can actually configure CloudFront to terminate the connection for you from your end clients, right? Also, another feature of a content delivery network is that they provide the ability to cache content, right? Now, you don't have to use caching. You can also proxy request through. There's plenty of benefits to just using a CDN without even relying on the caching to kind of bring that content closer to your users. We're not going to go deep into that now, but one feature that I really want to bring up here is, with CloudFront, we have a feature called Lambda Edge, where you can actually invoke Lambda functions on the request and response flow of the request. And by doing that, you can manipulate the request or the response on the way in or on the way out. There's 4 invocation points, 2 in front of the cache and 2 behind the cache. But it's one way to add this extra redirection logic without actually having to make changes to your core application, right? So let's take a look at how that could look. Right, so in our previous example, we locked the database, right? But rather than routing clients directly to the application endpoints in our corporate data centers or in our AWS cloud environment, we configure a CloudFront CDN in between, right? So it'll be a CNAME record, and then that backend domain, the origin.example.com, would actually point to our new target environment, right? When a request comes through, let's say CloudFront does a DNS query to its DNS resolver Route 53, and it's still getting the cached answer, right? So it's going back to the original corporate endpoint. Well, in this case, let's say the application returns a 403 response. Rather than proxying that back to the end client, what you could do is configure CloudFront to use Lambda Edge to catch that error and then generate that redirect response. Right? So here we generate that redirect response. It's a 301 back, and then the end user would continue. The end client would retry against that new domain, fetch it, and get a 200 response back ideally, right? Okay, so let's take a look at how complicated that is, right? Well, with CloudFront, there's some configuration in console or via API. However, if you look at the Lambda Edge code that you need to configure or you need to implement, it's just a few lines of code. It's just a few lines of code, right? This is your typical Lambda function if you've used this service before. There's an async event with an event object and a context as parameters passed in. And if we look at what that event structure looks like, it's a JSON blob that contains information about the CloudFront configuration, the request that came in, and the response that's going out. And with that information, you can build that into your logic to make a decision on how you want to handle that request. So in this case, we have an if statement that looks for that status code of 403. If there is an error, then we redirect it. So we update the status code. We add a new header to the response. Set the location to cutover-to-example.com, and we're on our way. Right. Okay. So now let's talk about gradual cutovers. So the last couple examples were just flipping the switch by configuring DNS. In this example, or in this part of the talk, let's talk about how we can move some of the traffic a little bit slower and maybe get a little bit more comfortable with our cloud environment before committing to a full switch. One of the ways of doing that is by using Amazon Route 53, our DNS service. Route 53 offers all of the capabilities that you would expect from a DNS service, like domain name registration, DNS resolution, but it also offers some pretty advanced capabilities around routing policies, right? So we have latency-based routing policies, geo policies, and weighted round-robin policies. And ultimately, what these policies allow you to do is to configure a portion of your traffic to your new target environment to kind of really trial it out, right? Maybe you want to start with just 5% of the traffic and then gradually ramp your way up to 100%. Right. So one thing that's worth noting when you're leveraging these routing policies with Route 53 is it works great if you have a stateless application. However, if you have a stateful application, it doesn't take into consideration state. So this is not something that you would want to use for those scenarios. So how would you handle that, right? Let's say you have a stateful application. Well, in the last couple of examples back, I talked about Lambda Edge, and again, we can leverage that capability in CloudFront to help manage stateful applications as well, right? So one of the ways that web applications work is by setting cookies in browsers. If you're not familiar, right, browsers cache cookies that are set by different web applications, and on subsequent requests to that domain, those cookies are forwarded along with those requests. And with that data, the application or the server knows what to do with the request and responds to it accordingly. So if you have a stateful application, you can leverage cookies to manage your state, right? And in this case, as part of a migration, we want to make sure that our end users are consistently routed to the correct endpoint, right? So with this example, you could configure a CloudFront distribution with a couple of Lambda Edge functions. And the way you would do that is you would use an origin request event. And what this origin request event would do would be it would check to see if a cookie exists. If it doesn't, it does a little coin flip based off of what random implementation that you implement. And then it'll determine which origin to route the request to based on that. If the cookie is already set, it'll use that value and set the origin accordingly. Right, and the origin is your application endpoint, whether it's in your corporate data center or in AWS. Now, on the way back, if the cookie hasn't been set, maybe it's the first request from this client, you can also inject the header to set the cookie on the client so that all subsequent requests continue to get routed to the same origin endpoint, right? Okay, so in addition to gradually migrating by using CloudFront or Route 53 with DNS, you can also cut over independent components within your application if you're architected appropriately, right? If you look at this example here, this web application, we have a number of different components. We have a profile, like it knows my name, right? It has a shopping cart, 3 items. It has static assets. We're selling zebras and unicorns. And then it also has dynamic content that gets updated as things are purchased, right? So if you leverage subdomaining, this will simplify your life when you're trying to move individual components within an application. So for this example, if we take note, right, I have a separate subdomain for the profile service, I have a separate domain for the cart service, I have a separate domain for the dynamic content, and then as well as the static content. And let's say I wanted to just move my static content to the cloud first and trial that out S3 buckets. Let's say I move all of my files into an S3 bucket off of my file servers. I could simply update static.example.com to point to that S3 bucket and then gradually move parts of my application over to the cloud, right? So take into consideration how you organize your application, how you configure your application endpoints. Now, I spoke a lot about CloudFront so far, and we talked about some of the mitigation techniques to deal with DNS propagation and so forth. But sometimes you may run into scenarios unexpectedly or expectedly where you're just going to have some errors during this cutover phase, right? And something you really should think about is how do you gracefully degrade the application for those scenarios, right? If an error does happen, you don't really want to send that kind of raw 500, 400, or server unavailable error to your customers. Something you can leverage within CloudFront to provide a better user experience is some of the native features. Custom errors, for example. If the server starts throwing errors, you can actually serve a static pretty page. And you might have seen this pretty page when you're using Amazon.com. Sometimes you might find that a nice picture of a dog with the oops, something happened, right? It's just much better experience for your customers. And sometimes you can also leverage stale caching. If you have static assets and the origin is down or that target endpoint is down, CloudFront will actually try to serve stale content from the cache rather than serving an error. And then the last thing you can think about is origin failover. If you have different endpoints, you can configure the CDN to retry against the second endpoint should the first one fail, right? So these are techniques that you can use to mitigate some of the issues that you could have during a cutover that you should keep in mind. All right, so now let's jump into database cutovers, right? I talked about DNS cutovers at the application endpoint before. Let's talk about those scenarios where we're just moving the data layer first, and specifically for this example, we're going to be talking about databases. As you know, migrating databases and data is probably one of the hardest parts of a migration. So you really want to take into consideration, what your rollback strategies are when you are cutting over to your new database endpoint, I should say. Okay, so if you're not already familiar, I'm not going to go too high level on this, but database migration service is a service that allows you to replicate data from your source database into the cloud at the database layer. And you can leverage this service when you're thinking about not just moving data to the cloud, but also when you're trying to figure out how to do fallback or rollback strategies, right? So in a basic scenario, let's say you have an application writing to your on-premise database. You could use database migration service to replicate that data into the cloud, and then when you're ready, you cut over that application to point to your new database. As the application is running, you're going to have new updates, new records written to that database, and if something unexpected happens or it doesn't perform as expected, you can just point your application back to your on-premise database. If you go with this route, you're going to lose that delta of data. Sometimes that's okay. Maybe it's a test workload, right? But many cases, data is critical, and you don't want to lose that delta. So what can you do? Well, another approach is to do the dual write approach, right? In this case, similar to the last approach, we replicate data with database migration service. And then from there, rather than just pointing the application at the new endpoint, we update the application code to write to both database endpoints. Right. This way we have an up-to-date copy in our on-premise environment while we're using the AWS endpoint. However, if something went bad and we had to roll back, we could simply just point our application back at the on-premise environment and then not have to worry about that loss of data. Well, as we talked about with the endpoint cutover technique, where adding application logic adds complexity to your migration, similar things happen when you're trying to do database migrations, right? Sometimes you just can't update your application code like that. So what else can you do? Well, another approach you can use is this fall forward technique, where in addition to having a copy of your database in AWS, you'd also set up a standby database back at your on-premise environment, and you'd use database migration service to replicate that data from on-prem to AWS, and then also from AWS to that standby on-prem database instance. From there, as new data is written, it continues to get copied through, and as you repoint your application to the AWS endpoints, right, your original database will become stale. If anything happened and you needed to go back to on-premise, maybe there was a performance issue or there was just too much latency or whatever it might be, you still have the option of falling forward to the standby database and have all of your data back on-prem available to use. Okay, now this fall forward approach, you can actually get pretty creative with it, and in some cases, you may be able to pull out piecemeal your migrations for just parts of your database, right? So let's say you had a decoupled table, an isolated table in that database, and you just wanted to move that table to the cloud, right, for an independent application that relied specifically on that table, just for example, right? In this case, you can configure a database migration service. You configure a task that just replicates that table. With the fall forward approach, you can also create another standby database in your on-premise environment. You can configure two additional tasks, one to copy the other tables from your on-premise environment to that standby database endpoint. And then also another one for the records that are updated in that AWS database endpoint back to your on-premise environment. This way, when you cut over that individual service, you can still have the option of rolling back to a state that was similar to with what you started, right? And this pattern can be used to gradually move components within an application. So you can just iterate and kind of work your way through that stack and migrate independent components accordingly, right? Okay, so in most cases, fall forward is going to be the approach that you want to go to. However, you want to really think through all these things before you kind of decide which way you want to go. However, sometimes fall forward and dual write won't work for you, right? In which case, database migration service also provides the ability to do bidirectional replication. And what we mean by that is, in this scenario, you can configure a couple of database migration service tasks that replicates data from your on-premise, changes from your on-premise data center to AWS, as well as from AWS back to your on-premise data center without dealing with duplication of records, right? It's really kind of designed for this fallback strategy, right? What it's not designed for is a multi-master scenario. So this is not something that you would want to consider for multi-master. However, you can consider it for, rolling back patterns like this, right? One of the challenges with this is it's very difficult to test your replication that's going back to the on-prem data center, because you won't have that, you won't have those changes, and you don't want to kind of test against that AWS database until you're ready to kind of send that traffic through. Something you can do is create another standby test database and create a similar task just to make sure that you have everything working. Okay, so that concludes the cutover strategies that you can use. What do you need to do after you've cut over, right? You want to continue monitoring your dashboards. Make sure that your metrics align. You want to validate your health checks. Any synthetic testing that you're doing, make sure that that continues to look good now that you have normal production traffic hitting the endpoints. You want to understand and communicate success so that everybody's aware where you're currently operating. You also want to update and test your runbooks now that you're operating in AWS. If you have any legacy runbooks that are referencing your on-prem setup, make sure they're up to date and applicable for those daily operational tasks, right? And then last but not least, you need to figure out when you're going to shut down your source infrastructure. Look out for data drift. If you're planning on rolling back at any point, make sure that you set a no return date and everybody's aware when you shut down that source environment, right? Okay, so let's reel it all back in, right? So you have your typical application stack. The first thing that you need to do is figure out how to route your end users there, and typically DNS is the mechanism to do that. You want to take into consideration that DNS does caching and mitigate where possible. You also want to consider DNS routing policies and think about how you can gradually migrate your end users to the new application stack. In some cases, you might be able to use the routing policies. In other cases, you might have to build application logic in for stateful workloads, right? Move independent components if possible. If you're architected to do so with decoupled components, consider leveraging subdomaining to make that process a little bit more easy. And then also consider using a service like CloudFront to add availability, scalability, and also, most importantly, for these cases, the ability to kind of extend your application logic to infrastructure outside of your core application stack, right? In terms of the data layer migrations, think about database migration service. Make sure you have a rollback plan, a fallback strategy, right? Think about how you plan on doing replication. Database migration service is a very good service for a number of different patterns. This is something that you can leverage as part of your migration. Okay, so with that being said, I'm going to leave you with some resources so that you can learn more about migrations to the cloud. We have a number of workshops, prescriptive guidance. That concludes our presentation today. Thank you so much for joining us, and please remember to leave your feedback and take the survey. Thank you, and have a good day.